In this video, we're going to be answering this question. So we've been told that a circle C has equation x take away 5 squared plus y plus 3 squared is equal to 10. And we've been told that line L is tangent to C and has gradient of -3. And we've been asked to find the possible equations of the tangents in the form y equals mx plus c. So when you have a question, a geometry question, it's often helpful to draw. So I'm going to just draw a picture of what's going on here. So, given our equation of the circle, x take away 5 squared plus y plus 3, we're going to know that the center of the circle is going to be at x equals 5 and y equals -3. So that's going to be somewhere about here. So let's call that point A. So A has coordinates of 5, -3. Now, we know that the radius squared is going to be 10, so then the radius is going to be root 10. And root 10 is 3.16. All we really need to know is that it's not going to cross this bit here, but it's going to cross this bit here. Because obviously, the distance from there to there, that's going to be 3. The distance from here to here, that's going to be 5. Root 10 is not greater than 5. Root 10 is greater than 3. So we're going to have something that looks a bit like this. So now we've been told that we have a line L, which is tangent to C and has gradient of -3. So I'm just going to draw these in roughly because we don't know exactly where they're going to be. But I'm just going to draw it about here. And then the other one, we're going to draw about here. So because they're tangents, they're going to touch the circle at exactly 1 point. And so that's going to help us as well. So now that we have this going on and we know what it's going to look like, you can actually start to solve it. So the first thing that we need to do is think about how we can start to find the equations of the tangents. And one of the circle theorems that we know is that from a radius to a tangent, it's going to be perpendicular. So why don't we just go ahead and draw in a diameter line through here. So diameter is just 2 times the radius. So let's draw this, and let's call this L2. Alright, so we know that the gradient of the tangent line is going to be equal to -3. So therefore we know that the gradient of L2 is going to be the negative reciprocal, which is just going to be 1/3. So therefore the gradient of L2 is going to be equal to 1/3. And this is because 1/3 multiplied by -3 gives -1, and when you multiply two gradients together, if they're perpendicular, then they're going to give you -1. So now that we know that this gradient here is going to be -1, 1/3, and we know a point on this line. So we can write an equation for this line now. So we know that the equation of a straight line is going to be y take away y1 is equal to mx take away x1. We know our set of coordinates A, so we're going to write A, 5, -3. We're going to call this x1, y1. And of course, we know our gradient, so m is going to be equal to 1/3. Substituting this in, we get y take away -3, which is just going to turn into a plus because negative is plus. So y plus 3 is equal to 1/3 x take away x1, which is take away 5. So now we can just simplify this. So y plus 3 is going to be equal to 1/3 x take away 5/3. Then adding 3 to both sides, taking 3 away from both sides, we get y is equal to 1/3 x. So our equation of the line is going to be y is equal to 1/3 x take away 14/3. So now what can we do? Well, we know that this line here is going to go through the 2 points of intersection of the tangent because we've worked it out to be perpendicular to the tangent. And we also know that it's going to cut through the circle at the tangent points. So what we can do is we can just substitute our value of L2 into our equation of the circle, and then the points where it intersects the circle is going to be the exact points of where the tangent intersects it. So let's do that. So let's recall that the equation of C is going to be x take away 5 squared plus y plus 3 squared is equal to 10. So then substituting this into here, because we're trying to find points of intersection, so we solve simultaneously, we're going to get x take away 5 squared plus, and I'm going to write this in a different color, so 1 over 3 x negative 14 over 3. Then we can close the bracket and add 3, and then that all squared is equal to 10. Now it's just a simple case of expanding it. So this is going to be x take away 5 multiplied by x take away 5, and of course that's just going to give us x squared negative 10x plus 25. So when we expand this now, we're just going to get bracket 1 over 3x take away, and then look, here we're doing negative 5 over 3 take away 3, so if we're adding the 3 back, then we're just going to go back to this. So it's going to be 1/3 x take away 5 over 3 squared, and that's just going to give us 1 over 9 x squared take away 10 over 9x plus 25 over 9. So now when we add these two together, so x squared take away 10x plus 25 plus 1 over 9x squared take away 10 over 9x plus 25 over 9, and we're going to see that that's still equal to 10 because all we've done is expanded it. So it's equal to 10, then collecting like terms, but first we're going to get rid of these fractions by multiplying through by 9. So 9x squared take away 90x plus 25 times 9, which is 225, plus 225. Then obviously we're multiplying by x, so these are just going to cancel out, so we're just going to get plus x squared negative 10x plus 25 is equal to 10. Then simplifying more, 9x squared and then x plus x squared, that's going to give 10x squared, negative 90x, negative 10x, that's negative 100x. Then 225 plus 25, sorry, this should be a 90. So 225 plus 25 take away 90, so 225 plus 25 take away 90, that's going to give plus 160 is equal to 0. Now this is just a quadratic that we can solve, so I'm going to do it on my calculator, but as said previously, you can do it any way you like. So 10, negative 100, and 160, we're going to get x is equal to 8, and x is equal to 2. Now all we have to do is put it back into our equation for the straight line. We can put it into the equation of a circle, but that's just long. So we're going to do the equation of a line because it's much easier. So then let's recall that y is equal to 1 over 3x negative 14 over 3. So then substituting our x values in, we get y is equal to 1 over 3 times 8 take away 14 over 3, which if we do on the calculator, we're going to get negative 2. Then if we substitute y is equal to 1 over 3 multiplied by 2, from here, negative 14 over 3. If we do this in a calculator, we're going to get is equal to negative 4. So therefore, let's call these points A and B. The coordinates of A is going to be, well, we can see that it's going to be 2, negative 4, because we can see that this is going to be roughly 2, this is going to be negative 4 roughly. So this is going to be 2, negative 4. Then obviously B is going to be the other one, so it's going to be 8 and negative 2. So 8, negative 2. Now that we have the coordinates of points A and B, and we know the gradient, we can work out the equation of the line of the tangent. So let's rewrite the coordinates over here. So we're going to do A first. So A, 2, negative 4. Let's call this x1, y1. We know that M is going to be equal to negative 3. So we can write the equation of a straight line. Y take away y1 is equal to M, x take away x1. Then we can substitute in. So y take away 4, which is going to be y plus 4, is equal to negative 3, x take away 2. So now we've been asked to put in a form y equals mx plus c, so we have to expand this and then put it into that form. So y plus 4 is equal to negative 3x plus 6, taking 4 from both sides, y is equal to negative 3 plus 2. Negative 3x plus 2. So then for the second one, we're going to do the same thing, but using our other set of coordinates. So this is going to be for b. So we know that b is going to be 8, negative 2. We know that m is going to be negative 3. So then writing the equation of a straight line, y take away y1 is equal to m, x take away x1. Substituting our values in, y take away 2. So y plus 2 is going to be equal to negative 3, x take away x1, which is 8. Then simplifying and putting into this form, y plus 2 is going to be equal to negative 3x plus 24. So then y is going to be equal to negative 3x plus 22. And these are going to be our equations for the tangent lines.